So on to the first talk for tonight. Introduce Scott Holden for putting the functions in your functions.
Hey. All right. Cool. I firstly have to apologize for the really bad title. It was one of those classic dad jokes that sounded fantastic in my head. I had a little bit of a chuckle. Putting the ctions in Azure Functions sounded awesome. Not sure if too many people got it. Anyway, today we're going to talk about developing, building, testing, and deploying Azure Functions. Basically all the cool stuff that you need to do to get a production-ready Azure Functions application. All the stuff that comes after the fun of spinning things up in the portal. To get a bit of a heads up before I start, how many people have worked with Azure in general before? Awesome. How many people have worked with Azure Web Apps, App Service Plans, or mobile apps? Cool. And how many people have worked with Azure Functions? Awesome. So we actually have a pretty good base understanding. So the first few slides will probably just be covering what you already know. From there, we're going to move into developing Azure Functions on your local computer, having a bit of fun within Visual Studio, and then moving on from there to actually deploying them and how we'll put them through a build pipeline to push them into a production system. So let's start by talking about serverless. Everyone loves serverless. It's the new buzzword. It's event-driven, pay per use, per trigger, Azure, AWS Lambda, Google Compute's offering, a couple of different options out there. It's scalable, it reacts to how many invocations you have. The biggest thing that I want you to take away from today, if you take nothing else away, is that serverless as a whole is a tool. It's not the golden hammer you should use to solve every single problem, but a subset of problems fit perfectly into the serverless model. Cool. So Azure Functions. You can write them in a whole lot of different languages: C#, F#, Node.js, Python, PHP, Bash, Batch. Basically, you can throw an executable at Azure Functions that can run on your Windows machine, and it'll work under Azure Functions. One of the biggest things is Azure Functions are trigger-based. They're traditional serverless, so they don't sit there waiting for something to happen. When an event happens or when you trigger a HTTP request, for example, it'll actually spin up the required resources to process that and process the event. There are two different plans for Azure Functions, if you've dug into it a little bit. You've got your consumption plan, which is pay per use, as well as running Azure Functions on top of an app service plan. So you can kind of think of an app service plan as prepaying for your compute and memory resources, so one CPU, 1.5 gig of RAM. Whereas consumption, you only pay for the time the function is actually running. And Azure have a little bit of a weird way of calculating this. They have their function execution count. This is normally the one you never hit on your free tier, but 20 cents per million executions. On top of that, they have a magical number of gigabyte seconds. So that's the amount of time your function is executing for per gigabyte of memory allocated at that point in time. So if you've got something that takes a gig of memory and runs for a second, that'll be half the cost of something that runs for 2 seconds and takes a gig of memory. So you can reduce the cost of your Azure Functions by either reducing execution time or reducing the memory requirement and memory footprint of your function. Cool. Let's have a chat about what sort of services we can design on top of Azure Functions and where we actually start to see some usages within a production space. So let's say, for example, we have table storage. We can basically call this any data source we want. It can be table storage, Cosmos DB, any data offering we want. We might want a way to actually get data out of that data source. So we can write a HTTP trigger in Azure Functions to pull that data out and return it as a HTTP response. This is nice because if no one ever wants to see your data, you never pay for that function's execution. If people only want to put things in and never retrieve, you never have to worry about executing that. We then come to the whole idea of actually inserting data. We could write an update function that directly updates that table, and that'd be awesome. Unless all of a sudden we got a couple of million update requests and locked up our data source. Instead, we can take a CQRS style and put a queue in the middle. And this is where Azure Functions work really nicely together when teamed up and linked with queues or event hubs. So we can use an Azure storage queue to detach our HTTP trigger from the actual update operation, meaning that if we have 1 million requests come in within a couple of seconds, we can service that, put it in the queue, and deal with it when we have the processing capabilities to do so, or when the backend resources are available. One nice thing that you get with Azure Functions and queuing in general is the ability to have poison queues or dead letter queues. So Azure Functions allows you to take advantage of this, and because a poison queue is just another queue, you can in turn add an Azure function to your poison queue. Say, for example, we might have some worst case scenario code that we really need to run in case of emergency, or if something fails repeatedly. We can simply attach an Azure function to our poison or dead letter queue, and then run that code on demand. So far, we've talked about putting and retrieving results, but what if, for example, we wanted to aggregate results and run something nightly? Azure Functions fits into this as well. We can use a scheduler either built into the Azure Functions framework or an external Azure scheduler to trigger a function. So for the 23 hours of the day that the function isn't running, we don't pay for anything at all. We have no compute resources dedicated to this, but when we're ready to execute this aggregation function, we spin up and take care of it. The only problem with this aggregation function is it might be a long-running process. So once again, we want to break it down and have as smaller function executions as possible. And like we did with our update operation, split it out using a queue. We can achieve this by taking our summarize function and turning it into a publisher of events to a queue rather than actually doing the work, and then have something separate, taking items off the queue and actually aggregating those results as appropriate. So what I've kind of designed here is the enterprise scenario for some random company. This outlines a couple of the different bits of functionality that can really help you design powerful Azure functions. The methodology of not actively doing work straight away, but instead putting it onto a queue and then processing it. Utilizing functions that may never be called really plays into the whole serverless role. For today, we're going to ignore half of this diagram and actually just talk about this component. So we're going to talk about the retrieval of information, so calling a service and retrieving that straight away, as well as putting an item via Azure Functions into a queue and then processing it. So to start off, I thought I'd run through Azure Functions inside the Azure portal. So what the first time experience is when you start off. So we're going to spin up a brand new Azure Functions project, possibly write a bit of code in the portal, execute it, and see what that looks like. You can kind of think of this as our before stage. So if I come across to the Azure portal, I can spin up a new functions application by going to the marketplace, going to the compute tab, and choosing functions app. Those who have mucked around with the portal a little bit will realize under the hood, it's just spinning up an ARM template for you. But we're going to ignore that for the moment and come back to that a little bit later on when we're looking at automating the deployment. So let's just spin up is that big enough for everyone to see? Cool. Let's spin up a altnet demo. Cool. So I give the Azure Functions application a name, and we can create it. While that's creating, I'll run through a couple of nuances and tiny bits to be aware of when you're working with Azure Functions. Because Azure Functions are built on Azure Web Apps, they require a globally unique name for the Functions application itself. That's whatever your function name is, .azurewebsites.net. This can be a little bit of a pain when you're first starting off because you may really want one specific name of demo or example.azurewebsites.net. But you can use custom domains to get around that whole naming thing. And as we'll talk about a little bit later, use things like Azure Functions proxies to get around that. So that's going to be spinning up right now. Let's jump in and have a look at the resources as they're provisioning. So the first thing we'll see when we provision an Azure Functions resource is a storage account. The storage account is used for three very important components. The first one is the actual storage of the Azure Function files themselves. So as opposed to a web app where the storage is abstracted from you, Azure Functions actually mounts the Azure Files component of storage accounts as the function storage. So once you've written your functions and actually published them, you can see them within the file Azure Storage Files space. Cool, that looks like it's spun up. So we'll also have the Azure Functions app service. Let's jump into there and have a little bit of a play. So by default, your Azure Functions app will have nothing in it. So we have no actual functions, no code to execute. And right now, we're actually sitting at one instance. So in the background, we've got one compute resource that's processing the requests for this portal alone. If I was to leave this for 20 minutes, walk away, it'll actually spin down to 0 resources. So if I was to open this portal again, it'd actually take time to spin up the first resource and deliver the content within the portal. So what you're actually talking to within this small blade of the portal is the Azure Functions host itself. So let's spin up a brand new function, and I'm going to build a custom function in C#, because alt.net, and we're going to make it a HTTP trigger. And I'm not going to write any code here, I'm just going to spin up a default one and we'll look how it actually provisions. So let's spin up a HTTP trigger. The only change I'm going to make here is set the authorization level of the HTTP trigger to anonymous, so we can just call it via the URL and not actually do anything. And we'll create that one. Perfect. What this has done is basically taken a set of boilerplate, it's taken a boilerplate template and put it into this function for me. What we get is a little bit of C# code, looks basically the same as a normal C# class. C# method without the class. And if we grab our function URL and execute it, we can talk to this function. Awesome. So we've actually got something up and running within a couple of minutes. The demo here allows you to talk to this HTTP trigger directly and see a welcome page. And then if you provide a name, it responds to you. But what happens if I come in here and I'm like, oh, I actually want to add something to this. So I'm going to go name equals name plus exclamation mark. Awesome. And I'm just going to save that. Cool. I'm going to save that, and I'm going to refresh my function. I'm going to zoom in, because everyone has seen that I've missed a semicolon, which brings me to my first point. In Azure Functions, designing in the portal, if you miss a semicolon because you're doing a presentation and you're under a lot of pressure, it brings down the entire Azure function for that execution point. So developing in the portal has a couple of drawbacks. In fact, let's cover those drawbacks now. So what we've done there is we've spun up basically a CSX file within the Azure function. You can kind of think of it as a C# scripting file. When the Azure function host starts up, it takes that CSX file, compiles it, and loads it into memory. So at the point that the host starts, it compiles everything, gets it ready to go, and is all ready. The problem is if you've got a syntax error, you've got a dependency that doesn't exist, or if you've referenced a NuGet package and it's restored incorrectly, your function is dead. Doesn't work. That's the biggest issue by far of just writing code straight in the portal. IntelliSense, I had to add that in there. You don't really get that nice IntelliSense in the portal. You get it in Visual Studio. Testing. Right there, I didn't really have a chance to run any unit tests. I didn't have a chance to test whether my code was valid. I didn't even get a chance to test whether my code compiled correctly before it was live. So writing directly in the portal doesn't give you the testability that you'd have in a traditional class library or console application. The last thing that is kind of true, kind of not true, is environmental promotion. If, say, for example, I was writing this in a development function, so right there I made my semicolon mistake and it was in dev, That's all right, it hasn't broken production. But the problem comes when I actually want to move that code from development to production. I either have to go through a whole lot of workarounds to try and get the code over there, and I may end up just copy and pasting the code between the two Azure Function apps, which isn't the nicest way to do environmental promotion. So let's have a chat about how Azure Functions actually work. And this is kind of the gateway into how to write Azure Functions as class libraries rather than within the portal as CSX files. So Azure Functions are built on top of the WebJob SDK. I noticed a couple of hands before when I asked about Azure App Services and web apps. One of the components within there is WebJobs. For quite a while, we've had the ability to spin up a long-running web job that reacted to queues, blob events, timers, and that sort of thing. Azure Functions is just actually an extension of that, where they've taken the WebJob library under the hood and added a scripting interface on top of it to react to events that happen. The biggest difference between a web job and Azure Functions at its core is that Azure Functions has an orchestration layer that Azure hides away from you. That's the thing that spins it up from 0 hosts to its first host, and then up to n hosts. Web jobs, you're completely in control. For those that are interested, the Azure WebJob SDK, as well as the entire Azure Functions scripting library, everything that there is to it is completely open source. You can jump in there, put in a pull request if you want to add something to Azure Functions. The only component that's not in there is that orchestration component that sits on Azure's side. The last thing I'll cover quickly before I move on to the next slide is bindings and triggers. Web jobs traditionally had the whole idea of triggering an event in response to something happening, whether it be a timer or a queue event. And Azure Functions brings across this mentality. And it also has the idea of bindings. So we may have a HTTP trigger, but we might also want to bind to a queue or to a storage account or to some other mechanism that we can trigger another event on. So within, okay, let's jump straight into that. Not the slide I was expecting, but cool. Let's jump into Visual Studio and actually create an Azure function. So we're going to do exactly the same example we just did in the portal, but we're going to do it on our local computer. So if we open up Visual Studio, highly recommend everyone get 2017 for this. You can do weird workarounds to get it working in 2015, and you can do this all manually yourself without using the Azure Cloud extensions, but this just makes it a whole lot easier. So Visual Studio now has a set of Azure extensions that you can update, which will include a brand new project type. And that project type is an Azure Functions project. So what they've done is they've taken all the hard work of having to manually build all the components to deliver an Azure function and put it into a template for you. So we're going to spin up a brand new function app called Function App 3, which is totally revolutionary. And right there, we get a couple of bits and pieces out of the box. The biggest piece we get is a brand new project type added to Visual Studio based on top of a class library that is a functions project. This is similar to a web API or web API in ASP.NET. The nice thing is it gives us a couple of custom types that we can make. So we can add a new item. Cool, there we go. Awesome. So we've got, apologies for the motion sickness. All right, so we've got our brand new functions application. I'll close this guy off. And we can right click, add new item. And it actually brings across a brand new Azure function item. And this, once again, is some boilerplate code that we can use to build our functions. You don't have to use this. This just gives you a bit of a head start when writing them. So we will construct a new Azure function called function1, original once again. And it's going to pop up with a very similar window to what we saw in the portal. In the portal, we were prompted with a whole lot of languages and scenarios that we might want to write code in response to. The Visual Studio IDE gives the exact same experience. So we can say we'd like a HTTP trigger that that has access rights as anonymous. So that's exactly what we did in the portal. Right now, we haven't talked to any external services. We're just on our computer. And we will create that. And open it up. Cool. How's sizing on that? Sweet. I'm just going to do a bit of code formatting so it actually fits on the screen. Awesome. So the code we have here is exactly the same code as we had in the portal. We've got some information happening, something happening within a HTTP trigger that returns a response. We've got our same querying the name. The only difference between the CSX code and the code we have here is this code is decorated with a couple of extra attributes. The biggest one being the function name attribute at the top, which defines that this is actually an Azure function. This is not just any generic public static async task of IO response message. This is actually an Azure function. And this is what's used by the Azure Functions SDK to generate the Azure Functions binding JSON in the background. As well as that, we've got a couple of extra bits and pieces. We've got a HTTP trigger listed. When we set up this new function, we said, hey, we want to respond to a HTTP request event. That attribute defines this Azure function as a HTTP trigger-based event. Cool. So this is all nice. We've got a nice little bit of code. We've got two options to actually execute this and work with it. The first one, which is the most common one, is right-clicking and going publish, and then importing the publish profile from Azure Functions. So we can download a publish profile from Azure Functions, put it into here, and publish directly up to Azure Functions. So your local machine can now deploy any code you write directly into your Functions app. But the second cooler way of running things is actually to run the entire Azure function locally on your machine. So instead of sending it to Azure, getting their orchestrator to spin up a host, you can actually run and have exactly the same experience on your local computer. And it's via the Azure Functions CLI. I mentioned before that the WebJob SDK has been around for a little while. People actually realize that you can take the WebJob SDK, put it within inside a console application, add the Azure Functions scripting library on top, and you've got a completely standalone instance of Azure Functions. This is slightly different to the Azure Functions runtime, which is actually running the full Functions runtime on-prem. This is more of a development tool. So we can jump in here and just execute our Azure function. So press F5, it goes along, it builds. The first thing we notice is it's actually building here prior to execution. The output that we get is compiled binaries. We're not shipping script files, we're not shipping anything special. Azure Functions is going to spin up, and it's going to look for all the functions that are defined within this project and hook them up and provide us with a couple of endpoints that we can hit. It's got some administrative endpoints that Azure Functions requires under the hood, but the biggest one, and I'll see if I can magnify again. The biggest one you can see is down the bottom here, we've got an endpoint for our HTTP trigger. So we defined via the attribute that we'd like a HTTP trigger. In the background, Functions went, right, let's hook this up, get you an endpoint that represents what you want. And we can now hit that endpoint and have the exact same experience we had within the portal. So if I grab that URL, paste it in, bang. Exactly the same as what we had over here, minus the error. And we can chat to it in the same way. Cool. The real power of developing Azure Functions locally isn't necessarily just the fact that you can run them locally, but you can also debug them locally. Because the WebJobs SDK is all .NET and it's loading it into memory, you can actually set a breakpoint within Visual Studio. Say, for example, we weren't sure what was happening in this return statement. We can add a breakpoint, execute our function exactly as we would in the wild, and drill into actually what's happening. So this gives us all the power of local development, building web APIs or console applications on your local machine, but using the Azure Functions framework for scalability as soon as it's out in the wild. Cool. Any questions on that bit? Yep.
What if your trigger type was queues?
Cool. There is, and I will actually get to that in a tiny little bit, because you can actually run the entire Azure experience completely offline without an internet connection. I'll get to that in a second. Any other?
Yeah, same in line with that.
Yep.
So you could have your Azure functions running locally,
Yep.
pointing to the remote Azure queues.
Yes, that's exactly it. So
The storage emulator.
yeah, exactly. So you can configure all of your storage account settings as you would in your production environment, pointing to a storage resource. Or the other nice way is you can actually use the local Azure Storage Emulator to emulate blob, queue, and table storage on your local machine and talk directly with that. Now, it's enough to get you started and enough to give you a half-decent development experience, but there are a couple of edge cases with the Azure Storage Emulator, especially if you're looking for bleeding-edge features. So what I'd recommend, if you're running into any odd problems, actually jump back and change to pointing it to a real live storage account, just to see if that's the issue. But we'll actually jump across and change to our second sample of today, which is that enterprise design that we had previously. The whole idea of having two HTTP endpoints, one to get, one to update information, piping that into a queue, and then actually responding to that. So the first thing that I'll point out is we've got two separate projects here. We've got one for our Azure Functions and one that represents our service. So our service has an interface which is a iData point service, which is very, very, very simple. There's a get and there's a put. Nothing more than that. From Azure Functions perspective, this is the best service in the world because it has a very simple DTO that it can send and receive, and it doesn't have anything fancy. So within our functions, we have two HTTP functions, one decorated with get, one decorated with put. You'll notice straight away that we have that exact same function name attribute defined at the top, as well as that we have our HTTP trigger set up. So we're saying both of these are HTTP endpoints. The biggest difference is that, besides the fact we're using a service locator pattern, is that our put operation isn't directly doing something. Instead, it's connected to a queue. So this is the first time we're seeing output bindings. So HTTP triggers, you can think of your inputs, your triggers, what actually starts everything off. But you can also define output bindings. So in a whole, this is taking in something as a HTTP request. It's then returning a response of 202 accepted. So it's responding back to the person that's triggered it. But it's then also putting something into a queue. Cool. Alongside that, we can also process item from a queue. So once again, we've got our function name here. And instead of a HTTP trigger, we've got a queue trigger. So we're responding to anything that comes into that queue. And we take our DTO directly. So we take our model, Azure Functions will take care of deserializing it out of the queue for us, and we can directly work on it. Because we've used a constant string for the two queue names, we can be assured that they'll be pointing at the same bit of storage. So where this becomes a little bit awesome is local.settings.json is the local settings that the Azure Functions CLI uses when it starts up. We can use this in conjunction with the Azure Storage Emulator to give you that local development experience. So by setting use development storage as true, it'll point to the Azure Storage Emulator running on your local computer. So right now I can disconnect from the internet, have no connection to the outside world, and I can run an Azure function that puts items in a queue and responds to those items. So we can start this guy up. Awesome. You'll notice that we now have two endpoints listed here with the same route. One will be marked as get, one will be marked as put. And we also have down here in our list of functions, we have our queue function of updating data. So if we take our get data URL and put it into Postman, we don't get anything back. We get an empty array. And we can come across to Azure Functions and see some information about that invocation. This is the exact same log messages you'd get within the Azure portal if you were looking at log streaming, or the same events you'll get in App Insights if you hook up App Insights with your function. We can then also come along and do a put request with some sample data. So just random data that matches our model. We can take that put request, and let me put this side by side. Cool. We can send that, and within here, we actually had two things happen. First of all, we had our update data, which is this first component here. So that was our HTTP trigger. So this was something that's called a HTTP endpoint with put and a model. We've responded to it and put it into a queue. We then have our second function down the bottom here, which is our update data queue function. So this has responded to something being added to the queue. You might notice that that was ridiculously quick, and our application took, 179 milliseconds to respond to a HTTP request, because it was the first request that's come into this function's CLI, and then 14 seconds to basically do nothing with the data besides store it off to the side. Awesome. So let's jump back into here. I'll skip through a couple of bits coming up. So we've seen that we've looked at two triggers and bindings so far, HTTP triggers and queue bindings. There's a whole lot of them out there. Microsoft.azure.webjob.extensions has a massive library of different bindings that can respond to different events. So we've got like SendGrid, Event Hub, there's some Event Grid stuff coming, as well as your normal storage, Cosmos DB, and HTTP. The other nice one in there is it's got a timer trigger attribute, which is an internal function scheduler, instead of using the dedicated Azure scheduler resource. Cool. So I'm going to do a quick bit on service design and what's worked for myself really well. One of the first things people do when they start writing functions in the Azure portal is they go, right, here's my entry point, here's my function. I'm just going to put as much in here as I possibly can. And before long, you end up with a 200, 300 line function that you're not really sure what's happening in there. One of the really nice things about being able to write these as class libraries is you can begin to design it in more of a service-oriented architecture style. Actually design a service and purely use functions as your glue. So design your service with common interfaces and DTOs, and then have your functions as small as possible. We've got a couple of examples internally where we have minimal code in our functions project. All it is literally taking an object, converting it to a DTO, and passing it to the service. They're the sort of designs that work really, really well. Because if tomorrow you want to say, well, actually Azure Functions isn't a right fit, let's make this a console application, or throw it inside a container, or do something weird with it, your service is good to go. Just a little bit of good design there. Ideally, your service shouldn't know about your functions, and your functions shouldn't know about the internal behavior of your service. Your service doesn't really need to know about the fact that it was function invocation XYZ that happened on this host and this sort of piece of information. It should just be worried about doing its job. Likewise, functions shouldn't really care about the internal workings of the service. I'm going to mark this with saying there's purely things that have worked for me. Take them or leave them, but it turns out well. Because when you move into the testing component of Azure Functions, this is where things become really tricky. You might have noticed previously that the method signature for our Azure Function entry points are static. That leads to a lot of problems. You need to start looking at service locator methodology to actually hook up services. That's a pain. If you begin to design your services as services and use function as glue, then you test your services. The bulk of your logic should be within your service anyway, not within your function method call. Function CLI, test locally. spin up a test that actually hits HTTP endpoints on your build server in a container running Azure CLI. Also, consumption plan is really cheap and free. You can do some amazing things combining that with the Azure load testing utilities. You can basically design REST API tests within their load testing utilities and have them execute every time you deploy to a function. By the way, I mentioned before service locator pattern. If anyone's interested about DI in Azure Functions, come talk to me after. Got some really cool stuff. Building. So once again, writing it in the portal, we didn't really build it. We put some code somewhere for a host to discover and try and compile. The nice thing about writing functions locally as class libraries is we can build them just like a normal application. We can call MS build and have our functions build. We can call MS test and run our test suite. We don't need anything special except MS build 15, but that's a requirement of the actual SDK itself. Bamboo, Jenkins, VSTS, there's a whole lot of stuff out there. The nice thing is anything that can deploy to a web app can automatically deploy to functions. So if you've got a, say for example, an Octopus deploy component that can deploy to a web app, you can use that already for functions. They're exactly the same thing. The final thing I'll just say quickly, use the build output when you're doing artifacts. So when you're gathering an artifact after you've built an Azure function, use the build output. Don't try and publish to a local file system. It doesn't fire all the targets correctly. So just a bit of a gotcha. Cool. So we're going to do a tiny quick demo on actually building and deploying these things. Rather than build up an entire pipeline, I'm just going to have 2 PowerShell scripts. I'm going to take a quick peek through them, provided I haven't run overtime. No, cool. I'm going to take a quick peek through them, see how we actually build and deploy an Azure function, and then we'll actually run them and get it deployed to the Azure portal so we can test this exact same function we've developed locally in Azure. So the biggest thing with deploying Azure functions is you need somewhere for them to live. And it's all well and good to open up the portal, go new Azure functions, type in some stuff and download the publish profile. But that becomes a little bit laborious, especially if you've got 2,000 builds a day. Azure have a really nice templating mechanism called Azure Resource Management Templates, or ARM templates for short. These allow you to declare the state the infrastructure should be in, and Azure will basically do all the hard work figuring out the difference between the two. So by default, if we deployed a template to an empty resource group, it'll calculate and say, hang on a second, I need to spin up this, 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 and this in this particular order, and then you're all good to go. So in this example, we're going to be spinning up an Azure function within Azure using a resource manager template. The biggest components that you need to know in here aren't the parameters, aren't the variables, they're just a fancy way of actually hooking up names. It's the resources themselves. So we've got a storage account. So this is the same storage account that was provisioned when we deployed Azure Functions via the portal. We've got a server farm. We said before that there were two different types of underlying hosts for Azure Functions, consumption plans and app service plans. In reality, they're all just app service plans on different tiers. So when we spin up an Azure function, we can spin up an app service plan in dynamic mode, which means it will scale from 0 to n hosts, rather than an actual dedicated app service plan, which will scale from 1 to n hosts depending on how much you want to pay. As well as that, we've got the actual function itself. So I'm not going to explain all the JSON, hundreds of templates available for free online. The Azure function itself is just a web app. It's nothing special. The only differentiating feature between an Azure function deployed using ARM templates and a web app is the fact that it is kind function app. That's the only differentiating feature. Everything else is just setting up some nice to have bits around it. We set up a series of properties. That's setting that storage account connection string and that sort of thing. It's setting up the file connection string and the file content share that it actually stores the Azure function files on. And something that it's a little neat trick to take home. If you add your function app edit mode as read-only, you can't edit it in the portal. That means if you've published it locally, you can't then try and edit binary files in the portal. I'm not sure why you would, but yep. The final thing we have in this template is the actual deployment mechanism itself. Because functions are web apps, we can utilize MS Deploy to actually get the files up there. And we have two different options. We can either push using web deploy, so actually say, hey, push these files up onto this web app, or we can get Azure to pull it for us. So we can use the MS Deploy extension to actually pull a zip file from, oh, pizza's here, sorry. To actually pull the files from a blob storage container, for example, and put them on there. So, build just calls MS build and packages it up and ships it to Azure Storage. I'm going to be really quick because I'm actually quite hungry as well. So here we call MS build, which is up a little bit. We start process MS build, we build it. This is exactly the same as everything you've been doing on your existing build servers. We then package up an artifact, so we actually zip up the build output of the Azure function itself, and then we upload it to Azure Storage. So that's all the build script's doing, is literally MS build, zip, put it in Azure Storage. The Azure Storage component could be replaced by whatever artifacting mechanisms you have in place on your build pipeline. In Bamboo, you can create an artifact. You can do it a number of different ways. The nice thing here is we can then use that URL of that blob to actually deploy. So when we push out our template, all we do is call new Azure RM resource group deployment, and it basically says take this template here and put it in this resource group and make sure everything here exists here. And that's it. So let's actually get this up and running. Let's jump in and build. So running the build script, we pass in some storage keys and storage account name. It just calls MS build. Once it's finished MS build, it's going to cross fingers. Try that again. There we go. It's going to compress all the files into a zip and then shove it up on Azure Storage. That's going to then give us a URL that represents this build's output. So we can put this wherever we want. I've put it inside the package URL variable, so you can't steal my SAS tokens. And so I can then reference it in our deploy. So here, let me scroll this down a bit. Here we're actually going to deploy that template with our package URL we just generated via the build. And we're going to give it a resource group to pass it into. And for the sake of this, we're actually going to go a brand new resource group that's never existed before. And it's going to go along, spin up a brand new resource group, spin up a storage account, spin up Azure Functions, spin up everything we need, and then pull the artifact we produced out of our build step into there. So by the time this finishes, we have an Azure function that's completely live that represents what we built on-prem. The nice thing here is in the build step, we could have run a suite of tests. We could have done our unit tests. We could have run a static code analysis over the top of it. You can do everything as you would a traditional build pipeline. Your deploy step is where your magic happens, actually pushing that out there. What I'd recommend, there's a lot of different methodologies around actually moving Azure Functions into production. Something I tend to do personally in personal projects is just deploy a lot of Azure Functions, like deploy thousands of them. Every single branch build, deploy Azure Functions. Because if it's never called, you never pay for it. So deploy them to everywhere, call your UI or orchestration tests on all of your services, and actually see what happens. This is probably going to take another 2 or 3 seconds to spin up, so I'm going to jump back to the slides very quickly to do my closing, and then everyone can get pizza and ask questions after. Cool. So what's new in Azure Functions? What's coming? Function slots, kind of useful. My view on it is, hey, just deploy lots of functions. There's not really a good reason to actually have slots when you can just deploy 2 functions side by side. Function proxies is like URL rewrite rules and application request routing on steroids in a serverless world. So you can define really neat things. So if you have 2 Azure Functions, you can create a functions proxy in front of them and actually switch between them. So via configuration, you can switch between two downstream sources. You can also do really nice things like lightweight API gateways. Say, for example, if you wanted to provision a large number of Azure functions, each of a different API version, you could use a function proxy to actually decide which backend resource to hit, depending on a query string parameter. The nice thing there, again, if they're never called, you never pay for it. If they're called a lot, it scales to respond. Also, Azure Event Grid, have a look at it if you haven't. Really cool new service. It's basically Azure Event Hub, just serverless. So webhooks, topics, subscriptions, you can do some really cool eventing stuff. What's coming? Bring your own bindings. The HTTP trigger and the queue binding that we saw before, soon enough you'll actually be able to write your own. That's in the WebJob SDK at the moment, but it's not officially supported. So keep your eyes peeled. There's been a lot of cool work for things like Slack bindings, Slack output, all that sort of stuff. Durable functions, which is basically the durable task framework that Microsoft wrote a little while ago on top of Azure Functions. So this is the same as having an async await workflow that's actually broken up onto Azure Functions for you. So you write a single method that has 3 awaits. Azure Functions Durable Task Framework will actually take that, split it across multiple functions, add in your callbacks for you, and run it as discrete functions rather than one large method. Also, .NET Core support, it'll be here soon. Really looking forward to it. What to look out? Emulating locally. Start the Azure Storage Explorer before you start anything else. Number of times that's caught me out has been hilarious. Singleton attribute isn't available in functions. That one will catch you out at some stage. Don't make the mistake of thinking it's there. It's just a race condition waiting to happen. Does your function have a function name? The number one thing that catches people out is you write a function, it's awesome, publish it, it's not available. It's because you don't have a function name. Also, big functions, keep them tiny. Keep your Azure functions as small as possible. I have a golden rule that if your Azure function execution time is over a second, then something's not quite right there. Either it's not a good fit for Azure functions, let's look at batch jobs, containers, container instances, that sort of thing. Or alternatively, can you split it up into more of a callback style where we offload to something and then return the result? I'm going to switch over to questions and pizza. Pizza mainly and questions after.
Just before I rush down to pizza, we do have a surprise second presenter tonight. Dave W. from StarRez has kindly put his hand up to be the second presentation tonight. So that will be on benchmark performance. So stick around.
Yep. Awesome. Yeah?
When you created your function as an output to a queue,
Yep.
why did you have to tell it to add an output to a queue?
As in what?
You had to put an attribute saying
Yes.
outputs was a queue.
Yep. It's because Azure doesn't actually know what you want it to be hooked up as. So I defined a generic type of iCollector saying it should collect something. It doesn't know if it should collect that into a service bus queue, an Azure storage queue, or what it actually is. So that attribute's actually just telling Azure Functions above it what it should be hooked up to.
Right.
Yeah. We'll have a chat later and I'll run you through a couple of things. Awesome. Anyone else? Cool. Pizza, go.